G'day team, welcome back to another induction video. Today we're going to look at how to do mathematical induction proofs involving matrices. So I've been given my matrix A, and that's to the power of 1, and that's 1, 0, 5 and 1. And then we've made a P of n statement here, so let's write that P of n in, such that A to the power of n is equal to 1, 0, 5n and 1. So let's go through our process of proving this. So, like any induction proof, we need a base case. So let's prove that now. So because we're dealing with a power, n has to be greater than or equal to 1. Otherwise, this matrix will just be 0. So no point doing it. So let's start with 1. Now the left-hand side is a to the power of 1. And the right-hand side is 1, 0, 5 times 1 is 5, and 1, which means it is true because we were already given that at the start of the question up here. So we just wanted to double check that. Now we assume that my P of k case is true. So assume pk, so a to the power of k is equal to 1, 0, 5k, and then not 0, but 1. Okay, so 1, 0, 5k, 1, and we're assuming that is true. Now, we want to prove that P of k plus 1 is true. So let's have a look at k plus 1. So a to the power of k plus 1 is equal to 1, 0, 5 to the k plus 1, and then another 1 there. So on the left-hand side, we can split that a to the power of k plus 1 into a to the power of k times by matrix A. So that's my left-hand side. So a to the power of k, we know, is 1, 0, 5 times k and 1. And that's just from our assumed pk case. And then a is just a to the power of 1, which we saw in our base case was 1, 0, 5 and 1. So let's do some matrix multiplication here. So my first row times by my first column, I've got 1 times 1 plus 0 times 5, so it's just 1. Then I've got my first row and my second column, I've got 1 times 0, which is 0, plus 0 times 1, which is also 0. Then I've got my first row and my first column, so 5k times 1 is 5k. Then I've got 1 times by 5, so I'm adding 5. And then I've got 5k times by 0, which is 0, and then 1 and 1, which is 1. Now, that nearly looks like what we want, but what we can do in this bottom left corner is take out a factor of 5. So then I've got k plus 1 here. Then I've got a 1, and that is now equal to my right-hand side, as we can see here. So we've got exactly the same. Therefore, P of k plus 1 is true. So finally, therefore, we've got since P of 1 is true and P of k plus 1 is true whenever, getting ahead of myself, whenever P of k is true, that means P of n is true for all n greater than or equal to 1 by PMI. Alright, so that ending sentence never changes. That's our sort of summation there. So now we're going to start doing some more strategies. So in this case, we've got matrix algebra. We've done some index laws previously. We've done some summation. We've done all that sort of stuff. So now we're all tying it together in our matrices. So with that, I'm going to leave it there, and we'll see you in the next video. Thanks.